just gonna make sure it's not so blurry. Okay, so today we're talking about probability and just a definition of some terminology that we have to know before we really get into things. An experiment, and this is more like a probability experiment, is a well-defined process from which observations may be made. Examples include tossing a coin and rolling a die. So your knowledge from the previous unit will really help you in this unit. Possible results of an experiment, those are outcomes. The possible results of rolling a die, or in other words, the outcomes of rolling a die, you can either roll a 1 or 2, a 3, a 4, a 5, or a 6, right? So you might consider rolling a die, right? For those of you who might not be familiar with dice. Possible outcomes of tossing a coin are head or tail, right? So, an event is a subset of all possible outcomes. So, for example, the event, for example, in this case, an event might be, examples might be rolling an even number, or, number, or rolling a number greater than 3. Greater than 3. Okay? So, let me spell greater a little better than that here. Greater than 3. Those are examples of outcomes, okay? Sorry, those are examples of events. Okay? So these are subsets of 1, 2, 3, 4, 5, 6, right? The probability of any event A is read the probability of event A equals the number of ways A can happen over the number of possible outcomes in your sample space. Okay? NS is the number of all possible outcomes. So in this case we have, if we roll a die, we have 1, 2, 3, 4, 5, 6 possible outcomes. The number of outcomes that belong to event A, well, let's say it's rolling an even number. So if event A is defined as rolling an even number, the number of ways we can roll an even number is 1, 2, 3. Probability for any event, A, we can call it B or C, is always between 0 and 1. 0 indicates that it's impossible for the event A to occur, and 1 indicates that A is certain to occur. What is the probability? Well, we had snow today. Well, it's 1 because we had snow, right? Probability we'll have more snow? Well, it's probably quite high. It's probably pretty close to 1 that we'll have more snow. Equally likely, there is no one outcome more likely to occur than another. It is assumed that tossing the head has the same probability as tossing a tail. So probability of a head equals the probability of a tail, right? That's equally likely. They're both equal to 1/2 because there's only 2 sides. Complement. The set of outcomes in which the event does not occur. Okay? So if the probability of rolling a head is 1/2, then the probability of not rolling a head is 1 minus 1/2, which is 1/2. The probability of not having an event occurs read as probability of A naught or not A. And we'll do examples to illustrate all of these new terms, okay? All right, and let's do this example. A random number generator is a computer program that produces digits from the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 with equal frequency. So that just means the probability of 0 is 1 over 10, right? Because 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 outcomes. So the probability of rolling a 0 is 1 over 10. The probability of rolling a 1 is 1 over 10. The probability of rolling a 2 is 1 over 10. They all have equal probability. What's the probability of event A? Well, event A is defined as even digits, and you know that's 2, 4, 6, 8. Okay, so the probability of A equals the number of ways A can occur over the number in our sample set, or our sample space. So, oh, I think I forgot a digit. Digit 0 is also considered even. So the number of ways that can occur is 1, 2, 3, 4, 5, so that's 5. The total number of numbers in our sample space is 10. So the probability of rolling an even digit is 1/2. Let's do the probability of B. Well, an 8 or a 9 occurs. Well, we need the number of ways B can occur over the number in our sample space. The number of ways B it can occurs 2 ways. You roll either an 8 or a 9, so that's 2. The number in our sample space is 10, so the probability of rolling an 8 or a 9 is 1 over 5. Probability of C is the number of ways C can occur divided by the number in our sample space. Well, a digit produced is less than 8. Does that include 8? No, it does not include 8. So it's only 0, 1, 2, 3, 4, 5, 6, 7. So there's 1, 2, 3, 4, 5, 6, 7, 8 ways that can occur. There's 10 in our sample space, and that is 4 over 5. Always reduce to lowest terms. Always reduce to lowest terms. Good? What is the probability of not selecting a prime number in a random selection of a number from 1 to 20? So a prime number is a number which is only divisible by 1 and itself, right? So if I were to list all the numbers that are prime, 1 is not prime by definition. The lowest prime number we can have is 2. So 2, 3, 4 is divisible by 2, so that doesn't work. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, those are all the prime numbers between 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8. So why don't we define P as our prime numbers, and we'll just write it maybe a little bit more nicely. Okay, so the number of ways P can occur is equal to 8. Now, they want the probability of P naught, so we know that will equal 1 minus the probability of P. Right? So a number is either prime or it's not. So we just go 1 minus that. So that equals 1 minus the number of ways a prime number can occur over the number in our sample space. So that's 1 minus 8, right? Because there's 8 ways a prime number can occur before 1 to 20. The number in our sample space is, well, there's 20 numbers. So that is equal to get our common denominator, and then we'll subtract, and we get 12 over 20, and that equals 3 over 5. Can I explain anything else or explain anything better? Anything you'd like me to explain better? Okay, that's it. Short lesson for a short period. Alrighty.